Hello and welcome to our STEAM project number 5, based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this intermediate level the Sherpa level. In this project, we are going to capture the readings from a temperature sensor and do some basic calculations with the data in MicroPython. My name is Peter. I am the founder of Educommando and a certified STEM instructor and course developer. The goal of today is to read the analog signal from the LM35 temperature sensor and show the averages of 10 readings in the REPL space. So we will introduce a new component, the LM35. We will also start with some basic calculus in MicroPython, and probably the most important, make sure that your class works as a team and optimizes their solution skills. Let's start by taking a closer look at the LM35. This small sensor resembles a transistor with its 3 legs. And just like most analog sensors, the LM35 has a volt pin, a ground pin, and an analog signal pin. And basically that's it for the theory. So let's see what we need for the project. We will need the following components: the large breadboard with the Pico installed, and of course the pinout reference card, the temperature sensor, a box of preformed wires and a bundle of jumper cables, and really that's it for the hardware. This is a very straightforward project, so your students will be able to build this without any issues. Give them a couple of minutes to put the components together. When everybody is finished, we can start with the programming. Let your students open Thonny and create a new file. As always, we first import MicroPython modules and classes. And for this project, we need the class ADC from machine and the class sleep, which we import from the time module. We need the ADC, or analog to digital converter, because we want to read a sensor's analog values. Next we define the pin, so temperature pin, temp pin equals ADC26. Because this sensor is quite sensitive and the readings can be quite different, we want to only display an average of 10 readings. Then the average of the next 10 readings, and so on. So this should give us more reliable and smooth readings. So first we need to define a counter. This will be a variable where the readings are added to one another until the total of 10 is reached. And we call this samples, and we set it to 0. We also need a variable that will keep track of how many measurements have been added. This will trigger the formula to calculate the average as soon as 10 has been reached. So this variable starts at reading 1, and we will call the variable sample count, and we set it to 1. Because we need to calculate from the analog reading to volt, the conversion factor is CONV equals 3300 divided by 65,535. And this is a good moment to ask your students what these numbers mean. Where do they come from? Okay, once they have explained that to you, we can start with the while loop. So while true, and we start with an if statement. If the sample count is equal to or smaller than 10, then we will say temp value is the temperature reading from the temp pin. And it's an underscore U16 because we know from an analog pin we can read these 65,535 values. Then our variable samples will be added with that reading. So samples equals samples plus temperature val. And the sample count will also be adjusted by adding 1. Else, so once this if statement has been completed and the 10 readings have been completed, we are ready to calculate the average. And we do that by defining a new variable, temp average, and that's temp value divided by 10. So temp value is the total of all the readings, the 10 readings, so we simply need to divide it by 10. So that's our new variable, but we also have to reset the counter, so the sample count has to be reset to 1, and the number of samples has to be reset to 0. And in our view, in our REPL, we want to see what's happening, so we print temperature in centigrades. And what do we print? We say the temperature average, and we multiply it by our conversion factor, which we defined previously. And we leave 1 second as a delay, or we put 1 second as a delay. So let's have a look if everything is working. If for some of your students it doesn't work, now don't panic. Together with them, you can do some logical fault finding. Were there any error messages in the REPL of Thonny? Did you select the right Raspberry and the correct comms? Did you connect the components to the right GPIOs? Are there any loose wires or loose legs? Or maybe you're just unlucky and you picked a broken sensor. Before we end this lesson, this is also a good moment to explain to your students that the Pico has an onboard temperature sensor. You will not find it on the pinhole diagram, but this sensor is linked to the 5th ADC port, namely ADC4. A great exercise or homework for your students is to let them write an additional program comparing the readings of the LM35 with the onboard sensor. Do you think that they are ready to do this on their own? Well, I think that they are. Another exercise is to let them measure the temperature both in Celsius and Fahrenheit. This will broaden their understanding that not everywhere in the world people are expressing temperature the same way. That's it for our 5th lesson. I hope you and your class enjoyed it. In our lesson number 6, we will learn how to build a cool distance measuring device with one of my favorite sensors, the ultrasonic sensor. Looking forward to welcoming you again, and bye-bye for now.